Here we are in the video series introducing functions and such, and we have all the basic ingredients of what the rules are with functions now. So you define a new function with the keyword def, you give a name for the function, you have parenthesis, and optionally you have parameter variables that are going to be inputs to the function. You have a colon, you have indented code, that defines a new function. When you want the function to actually run, to actually execute the code, you have the name of the function with parenthesis down later on, and you have arguments, values that will be passed into those variables. If there are any return statements, then that stops the function. It's done when the return statement runs, and that'll be the value that sits there when the function is over. That Python will continue on with that value. Alright, so those are all the rules. What we're going to look at in this video is using all that and kind of things getting kind of crazy. Alright, so if you don't like where we're at, then just don't watch this video because it's going to be a little bit more complicated. Okay, so don't proceed until you're comfortable with everything so far. Alright, let's say that you're comfortable. I'm going to run this code. We have three functions. There's fun1, fun2, and fun3. I'm just going to change some values here. So fun1, when I put a 3, so that's actually a 3, so the print statement there is wrong. So when I put a 3, there's a 6. When I put a 4, there's a 24. When I put a 5, there's a 120. So now, based off that pattern, and maybe you want to look at the code for fun1, what do you think fun1 is actually doing? Pause and make a conjecture. Did you make a conjecture? My conjecture is that this is computing n factorial, which in math is n times n minus 1 times n minus 2 times ... down to times 2 times 1. 3 times 2 times 1 is 6. 4 times 3 times 2 times 1 is 24. I didn't change this to be a 4. 5 times 4 times 3 times 2 times 1 is 120. Okay, so that seems to be what fun1 is doing. What fun2 is doing is more... I don't think that you'll necessarily guess what it's doing. Some people will, but a lot of you wouldn't. I think what fun3 is doing, you could see. I'm just going to get rid of that right there. So with a 4, it gave me a 16. I'm going to run it with a 2. It gives me a 4. Let's run it with a 3. 8. Okay. How about, okay, with 4 it gave me 16. With 5, 32. With 6, 64. So what do you think? What it's actually doing is it's doing 2 to the power of n. Each time n is 1 bigger, it multiplies by 2, 1 more. That's what 2 to the power of n means. And we could test that down here by saying 2 star star 6, that's the 64, 2 star star 5, that's the 32. And it's computing that in an interesting way. Alright, this one here, I'm just going to tell you what it's doing. This is n choose k. That's a thing from math, which is if you have n different items, how many different ways can you make a group of k? Alright, so you can work this out. I'll work it out down here. So let's try 4 choose 2. So let's let our 4 items be A, B, C, and D. Okay, so we can have AB, we can have AC, AD, we can have BC, BD, CD. I think that's it. The order doesn't matter here in this definition with N choose K. So we could have BA, CA. I think we got them all. So if that's true, 1, 2, 3, 4, 5, 6. I counted out all the different ways. So if this is actually computing and 4 choose 2, and if 4 choose 2 has that meaning that I'm claiming it does, I should get a 6 there. All right, we could try another one. 5 choose 2 with the 5 items. A, B, C, D, E. You can do that on your own. You're going to get the value 10. But it would be good for you to try that on your own, just to make sure. And the math definition of N choose K is N choose K is defined to be N factorial divided by K factorial times N minus K factorial. So we've got all these different math things going on. This is the definition of N choose K, and it works out that using this definition, it actually has this meaning, which is cool. But not the point of this video. It's just kind of something interesting. And it also works out that, so here we have this fun2. These are some of these N choose I's. If you add up all those N choose I's, the ones that I have here, it ends up giving you 2 star star N. It's a math theorem, which is kind of fun. All right, but what I want to look at is play computer with this. So without math about the formulas, okay, there's some functions there. I don't know what they do necessarily. Let's play computer to see what happens with the play computer, because it gets interesting. Okay, so we've got functions 4. We're going to have some globals. We're going to have a screen. All right, and we're going to start up here. We have our print cheers. We're going to have some functions that are available, fun1, fun2, fun3. And then we're going to get down to here. Inside of a print statement, before we can do the print, we have to figure out what is this value. So we're going to have to run that function. I'm going to put it, I guess, here. Okay, so we have to run fun1. And inside of fun1, there's a variable n. And I have fun1 of 5, so n is going to be 5 there. Okay, so I was going to come back to here, so I'll sort of put that I'm coming back to here. All right, so I'm ready to run this code. Is 5 greater than 0? Yes. So I'm going to do a return. I'm going to mark it here. Return value is going to be, well, I've got n, so that's going to be 5 times fun1 of 5 minus 1, 4. Okay, so that's a return statement, which means that when I figure out what this is, that's going to go back to the print. So I'll make a note of that. This value here is going to go back and get printed as part of the print. Okay, but in order to do that, I have to do fun1 of 4. And so what happens is I'm not done with fun1, but I'm going to have another fun1. that'll have its own n, and this one starts with a value of 4 instead of 5. And then I run it again. So this fun1 has its own, it's at its own place here. So it's running the code fresh. And this one is still waiting to be done. So it's like I had two separate copies of this. You could think of it that way, that there's one that's in the middle of running, and then there's another one that's in the middle of running. There's a way the computer can reuse that code, so it's really like two separate instances of the code running. All right, so this one I've got n equal to 4. I start up here. N is greater than 0, so we're going to do that return statement. The return val is going to be, okay, n over here, n is 4. 4 times fun1 of n minus 1 is 3. And that return statement, where is that going back to when I figure it out? That is going to go as the value of that fun1 of 4. That's where it came from. In order to do that, I've got to figure out fun1 of 3. So I'm going to start yet another fun1. Okay, so for this fun1, the value for n is getting set to be 3 initially. I run my code, 3 is bigger than 0, so I'm going to have a return value of, the formula is 3 times fun1 of 2. And when I get that value, where did that come from? The whole reason I'm running this extra fun1 is because of this. Alright, now I need to figure out fun1 of 2. So fun1 again. I've got an n value of 2 that came from here because that's what I'm trying to figure out. I'm still going to be in here, so I'm going to have the same business with a return value of 2 times fun1 of 1, and whenever I figure that out, that's going to go here. Okay, now I need to figure out fun1 of 1. You can see that we're eventually going to be done here, but we're not there yet. So we've got fun1 of 1. That's still bigger than 0. Return value is, the formula is 1 times fun1 of 0. And whenever I figure that out, it's going to go there. This whole thing will be that value. Okay, so now fun1 of 0, and we're finally going to be done. So fun1, the n value is 0. Okay, so now we finally are not doing this business, which is good, because if we kept doing this business forever, we'd keep getting more fun1s forever. We don't do that. With n equal to 0, we just return 1. So return value is 1, and that goes there. Okay, and we have a function that is finally done. Fun1 of 0, it's over. We have a return statement that actually finished. So this memory that we have to keep track of this stuff is going to be gone. The only thing that survives is the return value that comes back, which was a 1. So I should put a 1 there. There's a 1 going back. All right, so then this fun1, it was computing its return value. It was just waiting for this 1 to come back. So this whole thing is going to be a 1. Let's see. Let's put a 1 there. Can we put a 1 there? All right, it let me put a 1 there. Good. Because 1 times 1 is 1. And when we figure out that value, this function is done. That memory is gone. All that survives is the return value, which was 1. Now we have a more interesting return value. This is 1, that's 2, so aha, we finally get to say something that's not 1 there, coming back. And then this, once we figure out that return value, this version of the fun1 function is now done, and we're working our way back up. So this was 2 times 3, that's 6. Okay, so that's a 6 coming back there. This fun1 will be gone. We've got a 6 times 4, which will be 24. Once we figure out that return value, this thing is gone. Now we've got 5 times 24, which is going back to the print, which was coming from over here. So that is going to be fun1 of 5 equals, and we've got a 120 there, and then this fun1 function is done. All the fun1s are gone, and all that's left is the final value was 120. Okay, so we could keep playing this game. We made it all the way out, and we would go into fun2. And what would happen with fun2? I'll just start, but we're not going to go through the whole thing because it's a lot of this kind of stuff. So we go into fun2. Now fun2 has 2 values going in and 2 variables, so there's going to be an n, and there's also going to be a k. And they just get matched up by position. The 5 goes in to the n, the 2 goes into the k. And then this code is going to run. So the value here is going to be fun1 of 5, which we just know all of this is going to happen again. So there's nothing in our code that tells it, hey, I just did fun1 of 5. This fun1 of 5, it's going to run. So it's going to do all of this stuff again. I'm just going to say etc. ... to say that we stopped. I'm going to stop playing computer here. We would get all these fun1s again, and we'd have a value. And then we have 2 more fun1s that would go through a similar kind of process with different numbers. When we get to fun3, it gets even worse, because what happens inside of fun3? Okay, so we'd have a fun3. Inside of fun3, we call fun2. And that fun2 calls fun1. So we have all these fun1s, 2s, and 3s. I do want to show what this looks like in the debugger. So I'm going to pull up the debugger. So before we do that, if you want to pause here to process, go ahead and pause. All right, I'm going to run this now. All right, we're at the top with our print. I'm going to step over. There's a function, there's a function, there's a function. I'm going to step. It's either going to step into the print function or into the fun1 function. I want to go into the fun1 function to see what happens there. So let's see. All right, good. We're in the fun1 function, and this should match up with what we did over here. So because really the debugger and Play Computer is the same. It should match up. So we've got n, which is 5. Inside this says we're in a fun1 function. So I'm going to step. 5 is bigger than 0, so we're going to do this thing. And we're in another fun1. So that's this one right here with n equal to 4. And we can see this one is still waiting to finish. This fun1 is waiting to finish with that formula. This n equal to 4 is checking this if. We're going to this line. It needs to run fun1 again. I'm going to go all the way until we get to 0. All right, so we have all these fun1s that are open, and we can click on them. So there's the n equal to 5, 1, the n equal to 4, 3, 2, 1, and then the one with the 0. We know the one with the 0 is going to send back a 1. So it's going to go and return the 1, and then all the rest of these will be returned as well. So at this point, this is the picture on our computer, and this is what it looks like in the debugger, where you can scroll through. If there were more variables inside the function, we would see more than just n here. But so those are the different fun1s that are still running. Okay, I'm going to step. All right, and so we got that value, and I'm inside the print function. I'm going to go out of the print function. And if we go back over to our shell, there's that 120. And we should be, there we are in the fun2. Let's just go into the fun2 just as far as we did over here. Okay, so over here, I didn't want to go inside of the fun1 function, but if we did, we'd see all this business, so we'd see a whole line of fun1s here. We do see the K2 and N5 as the variables inside of the fun2 function. If we wanted to see what happens without having to run inside of all those fun1s, we can say over. So that skipped past the fun1, just got the value. If we just pretend that we know what fun1 does and we don't have to go inside of there anymore, then we could go over. In this formula here, it took the value that was there, 120, and divide by fun1 of 2. And now we're going to divide by fun1 of 3. And then that value is ready to return, and that came from this print statement. We're inside the print. If I go over to my screen, there's my 10. Okay, so what's the point? Weird stuff can happen, and it could happen because we're specifically designing it to be that way. I'm designing the function to work this way. Okay, it's supposed to do that, and this one's supposed to do this. But we can trace through it if we just get the order